Hello everyone. In this video, we are going to discuss the work done by the gravitational field, and we will also discuss the work done in the gravitational field is path independent, and we will prove that the work done in a closed path will be equal to zero in gravitational field. First of all, we consider this diagram. Here we have a mass m of object of mass m here place at point A, and we will take it the mass m from point A to the point B. To take the mass m from the point A to point B, we have three paths here available. There are infinite paths, and we considering just here three paths from A to B, direct A to B, and we can take the mass m from point A to C, first C, and then from C to then D. And second path can be considered as from the A to D, A to D, and then D to B. This path is called the second path, path 2, and the first from A to C and then C to B is considered as path 1. And if we take the mass m from just point A to direct point B, in between the x-axis and y-axis, this is called the path third. First of all, we consider the first path, path 1, which is as mentioned is A to C and then C to B. If we consider the work done, calculate the work done from A to C and then C to B, which is equal to the W1. The work done in path 1 is equal to the work done from path A to C and plus work done from path C to B. As we know that the relation of the work done is equal to F dot D displacement and plus F dot D displacement for both work. F force, uh, if we open the dot product, the Ft cos theta and plus Ft cos theta. As gravitational force is always downward, then the F and D displacement from A to C. For the A to C, the D is displacement and cos of 90 degrees plus F, and there is a height h for C to B, then F h and cos of 180 degrees, because our displacement is vertically upward and gravitational force is vertically downward. The gravitational force is vertically downward. The both are anti-parallel, then angle between force and displacement will be equal to the 180 degrees. As cos 90 becomes 0, this term will become 0 and plus F, the force near the gravity, near the earth, the force will be equal to the weight of the object, which is mg, and h, and cos of 180 will become minus 1. And the work done, first work done, W1 will become equal to minus mg h. Now consider the path 2. Path 2 means A to D and then D to B. Here the work done W2 will be equal to the work done from A to D and plus work done from D to B. As here in path 1 we have shown that the work done along the x-axis is equal to 0 because there is a cos 90. In this path 2, also the work done from D to B will be equal to 0 because here the gravitational force is downward and gravitational force is downward and displacement is along x-axis and the angle between the displacement and force is equal to 0. Then the work done from D to B is also 0. This work done will be equal to 0 and the W2 will be equal to the work done from A to D is equal to F dot D, which is equal to F D cos of theta, and this is equal to 0. The W2 is equal to F force is equal to the weight of the object near the Earth's gravitational field, and D is the edge height and cos of 180 degrees again, and will become minus mgh W2. Now we consider our path, third path, which is straight from A to B as mentioned there. Path 3. We know that the path 3 is in between the x-axis and y-axis, and here the work done will be both the displacement will both in x-axis and y-axis. If we consider this path as the components of x-axis and y-axis as stairs, we know that the stairs are displacement in x-axis as well as in y-axis. Then as we consider in both cases the path 1 and path 2, the displacement along the x-axis will be equal to 0, and this displacement along the x-axis will be equal to the 0. We divide all the path into two displacements, x-axis and y-axis, and the y component, this y component, let it's a y1, it's y2, it's y3, and then so on, the yn. But the displacement along the x-axis of these stairs is equal to 0. The path 3, the work done of 3 is equal to the work done along x components and plus work done along the y components. As work done along the x components is equal to 0, then the work done is equal to the work done along the y components. The first component W1 plus W2 plus W3 and so on. Say we have the n steps of this ladder, and along the y component. The first work done will be equal to minus mg y1 plus minus mg y2 minus mg y3 and then so on. Minus mg is common, and the y1 plus y2 plus y3 plus so on last yn. If we add up these all displacement along the y components, the y1, y2, y3 and then so on, it will become the height h, and then work done W3 is equal to minus mg h, which is also equal to the work done W1 or W2, which are the work done from path 1 and path 2. From equation 1, Equation 2 and equation 3 is equation 1, equation 2 and equation 3. We have concluded that the vector in a gravitational field is path independent, is minus mgh. If we calculate the work done in a closed path from A to C, then C to B, and then B to A, the work done, if we calculate the work done from A to C, then C to B, and then B to A in a closed path, then it will be equal to, the work done is equal to, the W will be equal to the work done from A to C plus work done from C to B and plus work done from B to A. As we know that the work done from A to C is also here in our path 1, which is equal to the 0, because it is in this path A to C, the displacement is along x-axis, plus the work done from C to B, which is equal to the minus mgh, and plus work done from B to A, and B to A is work done. We calculate the W3 in equation 3, which is minus mgh, because it is the work done from, the W is work done from A to B. If we calculate the B to A, then it will be the positive mgh. The magnitude will remain same, but it will be the positive, and these two terms will cancel out because of plus and minus, and the total work done will be equal to 0. If we calculate the work done in gravitational field in closed path, then the work done will be equal to 0. These two conditions of the work done remains path independent and work done in a closed path is equal to 0. These conditions satisfy the conservative field. The what conservative field is? The gravitational field is a conservative field because here the work done in gravitational field is path independent, and also the work done in a closed path is equal to 0. Hence we can say that the gravitational field is a conservative field. Thanks for watching.